Okay, thank you. Good afternoon, everybody. Modeling of immune system using epistemic Lukasiewicz logic. Yes, internet. In abstract, we introduce a new logic, Modal Epistemic Lukasiewicz logic, ELP, which is an extension of the infinitely valid Lukasiewicz logic, the language of which is extended by unary connective that is interpreted as a modal epistemic operator, knowledge and quasi-knowledge, and by the axioms of the logic of perfect MV-algebras. A relational system is developed as a semantic of this logic. The relational system represents the immune system, which in its turn is a part of relational biology. The adequate semantic for the new logic are special relational systems named C-valued Kripke frames. Moreover, we represent some immunological systems as relational systems. More precisely, we show that some immunological systems described as relational systems are Kripke models of the logic. Now, about mathematical logic, I want to say some words because mathematical logic is also named a foundations of mathematics because as a formal systems, the mathematical logic is a universal language, having universal languages, having especially the first order system or a second order predicate systems also they have the universality property. So we instead of the classical logic, we use Lukasiewicz logic, which we think that it is convenient for immunology, for immune systems.
REVAZ, may I ask you? So Simone is not seeing the slides. Is anybody else having problems seeing the slides?
I see them.
Yeah.
Okay.
Yeah, Simone, I think it may be on your side. I don't know.
Okay, thank you. Thank you.
Okay, good. Please continue.
It's okay. Now, the first attempt to study systems biology by means of logic, an axiomatic formal system, belongs to the Woodker. His publication is The Axiomatic Method in Biology, Cambridge University Press, 1937. He proposed to discuss biology with precision of statements and reliability of reasoning. Here we also should to mention Rashevsky. Rashevsky organisms or organismic sets. Und Rosen, a relational theory of biological systems, Bulletin of Mathematical Biophysics. And Rosen also a representation of biological systems from the standpoint of the theory of categories. Rashevsky was founded relational biology, that is the study of biology from the standpoint of definition of relations between the parts of the biological systems. Yes. Okay. Then, relational fragment of the immune system. Now, what is it? The immune system consists several types of cells of immune systems. There's T cell, thymus-derived lymphocytes, B cells, bone marrow-derived lymphocytes, NK cells, natural killer cells, TH cells, T helper cells, TH1, TH2, TH17, and so on. TC cells, cytotoxic T cells, memory T cells, subset of antigen-specific T cells, NKT cells, natural killer T cells, Phag cells, phagocytic cells, APC cells, antigen-presenting cells. This is a main part of the elements of the immune systems. We can represent this by the diagram is TC cells, NKT, and so on, and interrelation between them. Also, such kind of picture we have. There is also more detailed for immune systems. Also, this one, also we have such kind of picture for immune systems. The immune system consists of the special kind of cells, T cells, well-educated and clever cells, which are interrelated and afterwards is revealed on their behavior. So the behavior depends on the knowledge information that T cells possess about environment and other T cells. The immune system is very important for human. We know also that immunology is also the important part of biology also. Now, the modeling of immune system, yes, we study logical system and their semantics, algebras and relational systems with application for immune systems. The language L of Lukasiewicz propositional calculus contains a countable set of variables, of propositional variables, logical connectives, implication, negation, equivalence, and so on. I want to say that language is an important part of any sciences. For investigation any sciences, we begin what kind of language the science use. For example, the language of mathematical logic is more universal language. They have anything, especially if you take first order predicate logic. There are functional symbols, predicates, also individual variables, constants, and so on. It is also only symbols, nothing else. Symbols, and then by this language we can construct an expression that names formulas. It means formulas, and from the set of formulas we take a subset that names axioms, and then inference rules. If we have the universal formal system, that other mathematical objects, take an algebra, maybe geometry, group, and so on, it depends what kind of languages and what kind of symbol of languages we take. And then interpretation in the subject, in the object that we investigate. For example, algebra, geometry, maybe physics, biology also, and so on. So we introduce a new modal epistemic Lukasiewicz logic, ELP, obtained from the infinitely valued Lukasiewicz logic L by adding one axiom of the logic of perfect MV-algebra, LP, the language of which is enriched by quasi-knowledge operator, connective, the box Q superscript with corresponding axioms. That LP, the system of perfect MV-algebra, was introduced by Nola and Lettieri, and then Belus also, Nola, Gerla also have some results about these perfect MV-algebras. We define knowledge operator also box as box Q, the strong disjunction, and box Q also. Now, I want to say that the strong disjunction is different from the ordinary disjunction. For example, if we take classical logic, the disjunction we have as a maximum of 0, 1, also maximum. But if we take the interval 0 and 1 interval, then strong disjunction, if you take the two numbers x and y before the 1/2, then strong disjunction will be, say, 1 plus, as a plus operator, which is more than maximum. The knowledge operator may model a different type of knowledge that an agent may have. Now, any element of the immune systems, maybe this T helper cells and so on, we can understand as an agent, We have such kind of type of knowledge. Veridical knowledge, everything they know is true. This interpretation. Fuzzy knowledge, everything they know is quasi-true. Positive introspection, they know what they know. At negative introspection, they know what they do not know. Now, the language of Lukasiewicz logic is propositional variables, P1, P2, and logical connectives, implication and negation. And now we have these axioms that was formulated by itself, Lukasiewicz also, for axiom is one. Alpha, beta is any formula in the defined on the language of this Lukasiewicz logic. The inference rule is a modus ponens. Phi, if we have phi and phi implication phi, from these two formulas, we can infer the formula psi. Any formula that we can infer from this four axiom is named theorem, is a theorem. Now, how we can interpret it, this operator. Box alpha. It means that the agent knows proposition alpha. Box Q alpha, the agent quasi knows proposition alpha. In diamond alpha, the agent does not know that proposition alpha is false. And diamond Q alpha, the agent does not know that proposition alpha is quasi false. With some interpretations. Now, in the publication Nola, Grigolia, and monadic MV-algebras, monadic Lukasiewicz propositional calculus contains Lukasiewicz logic and the Lukasiewicz logic also satisfies the axioms. We have axiomatic of Lukasiewicz logic, and additional, we have these boxing axioms, say M1, M2, M3, M4, M5, this one. The inference rules also we have phi and phi modus ponens, and from phi we can deduce box Q phi also, with Q also here. ELP contains MLPC, satisfies axioms L1, L4 in the upsides, the slides. M and M is 6, and also additional axioms LP. This one. This is strong disjunction, this is strong conjunction, it is equivalence also. Now, what is MV-algebra? MV-algebra was introduced by Chang, but MV-algebra is the algebra with the type of this one, 0, 1, and 2. This constant and this operation of negation and plus, psych plus, is an abelian monoid. Abelian monoid. So it's plus is associative also and the commutative, and negation also we have the also and constant 0. It is involution negation because negation x is equal to x, and x plus negation 0 is a negation 0, and y plus, so this equation also satisfies. But for this, if the algebra, this signature is satisfies these axioms, it's named MV-algebra. The examples of MV-algebra is if we take 0, 1 interval, closed interval, is MV-algebra where x plus y is minimum 1 and x plus y, and negation x is 1 minus x. No, this one like in the classical logic also we have. And we said 1 equal to negation 0 and x multiplication is like De Morgan law. We define this multiplication. It's plus and multiplication. Okay. MV-algebras are algebraic semantics of Lukasiewicz logic. In general, MV-algebra cannot be semi-simple. What is semi-simple? The intersection of its maximal ideals, radical, is not equal to 0. The ideal containing only one element, 0. It can have a non-zero radical. Yes. Non-zero elements of the radical are called infinitesimals. There is no n such that nx equal to 1. It's meant infinitesimals. A first example of non-simple MV-algebra chain, MV chain, was given by Chang, where the MV-algebra C is described. No, as a this algebra is defined as follows. We have the C, this set, but then more clear I give you next slides. Then we define this operation. No, it's very difficult now to understand everything, but if we take the next slides, this one like this, the 0, the least element, and then C, the atom, then C plus C is 2C, and so on. And this is a radical also. Radical. This is congruence relation also we have, and if we have the factor algebra of C, of this algebra C by this radical or ideal, we take two-element Boolean algebra. Now, as you see, that is natural numbers, see, natural numbers, and no, as a ordinal, omega, and reverse on omega is omega star. This is this one. It is ordinal sum of this one. We have this algebra. It is very clear. The algebra C is simplest in the algebra with infinitesimals. In fact, C is just made of infinitesimals and co-infinitesimal elements. So C is the join of two infinitesimals and co-infinitesimal elements. Any non-semi-simple MV algebra contains a copy of C as a subalgebra. C generated by its radical, and C is equal to radical C joined with negation of radical C. C, as I said, that C by this radical is an ideal, isomorphic to two-element Boolean algebras. Up to infinitesimal elements, it's like the Boolean algebra. C generated by an atom C, which we can interpret as a quasi-false truth value. What we now give, what is quasi-true, and so on. The negation of C is a quasi-true value. If x is a quasi-true, then x multiplied n times x degree n is also quasi-true. Quasi-true values are the co-infinitesimals, is negation of also infinitesimals elements. Quasi-false values are not infinitesimals. By contrast, there is no notion of the quasi-true in the algebra of 0, 1. We have no the infinitesimal elements, satisfying the previous statement. Yes. Now we define a monadic MV algebra. Monadic MV algebra. It means that this algebra, it's A. The type of this one, 2, 2, 1, 1, and 0, 0. In this signature we have is an MV algebra and E satisfies the following identities. This special case, the A, is the behavior of this operator as a modal operator. The behavior as a quantifier, existing quantifier, also because there's such kind of notation we have. And also this for all x is equal negation and exists and negation x, like in the classical case. MV algebras generated by the infinitesimals called perfect. They form a subcategory of the category MV algebras. The class of perfect MV algebras is not a variety. The variety generated by algebra C is denoted by VC, and its algebras is VC algebras. The class of perfect MV algebras is included in variety VC. It is subset of the variety of VC. The variety of algebras is the class of algebras they are closed by the operation of homomorphic images, subalgebras, and Descartes product also. From the variety of monadic MV algebras, MMV, select the subvariety, MMVC, which is defined by the following equations. Perfect. With this one, 2 x square, and is equal to 2x and square. Now we obtain MMVC is MMV with monadic MV algebras plus this also this equation. Perfect. MMVC algebras are the algebraic counterpart of f of ELP logic. It is our logic now in this case. A formula phi of the logic ELP is a theorem if and only if it's valid in all MMVC algebras. This is a completeness theorem of this logic. It's a completeness with respect to the algebras, MMVC algebras. Like in the classical case, the classical logic is complete with respect to the two-element algebra, two-element Boolean algebras on the class of all Boolean algebras also. But in this case, we have MMVC algebras. Now, we define what is Kripke frame. Kripke frame, this introduced by Kripke, also is named Kripke frame for intuitionistic in modal logic also. W is non-empty finite set of possible words, and R is a binary relation, which named accessibility relation is reflexive and transitive. Now, what is C-valued Kripke model? It's a pair, J is a Kripke frame, and E is a evaluation. Evaluation from it is a function. If we take the variables of the logic and Descartes product of the W with W, this one is evaluated to the C as an evaluation function. It's named evaluation function. If EAP omega W is equal to 1 and W prime belongs to R, then EAP W prime also equal to 1. This property of this one. If EAP belongs to not radical, or said not negation of radical, yes, coin infinitesimals, and W prime belongs to R, then A, P, A, W prime belongs to also this not co-radical, this one. These definitions now. If phi is a propositional formula of LP, then EF, the evaluation is belong to C, the algebra C. If phi is a modal formula, then E, diamond Q, phi, and W, yes, W is equal to this function, to this is a maximum, the greatest maximum of these elements where W and W belong to R. And the box Q evaluation is a minimum, the least element, infimum, the A phi W prime, where W prime belongs to R. This definition, what kind of evaluation we have for this logic LP. A modal formula phi is said to be modally valid when it is evaluated to 1 in all finite Kripke models. Modally quasi-valid when it is evaluated to an element of coradical in all finite Kripke models. Modally 1 satisfiable when there is some Kripke model and some word W such that E phi W is equal to 1 in this model. Modally quasi-satisfiable when there is a some Kripke model and some word W such that E phi W belongs to coradical. Such. The theorem now sound is, if phi is a theorem of the logic ELP, it means that the phi we can derive from the axioms and inference rules of the logic ELP, then phi is modally valid soundness. And completeness, any modally valid formula phi of the logic ELP is a theorem. So a formula phi is a theorem if and only if it's modally valid. It's complete theorem in this case. Now, let W be non-empty finite set of possible votes. We have the Kripke frame now, J, and R, an accessibility relation, is a reflexive and transitive. Now, with immune system, EMS, is represented as the set of T cells with some actions between them. Identifying T cells with an agent or possible words and an action between T cells with the relation between agents, so we can represent immune system as a C-valued descriptive Kripke frame. G is a J is Kripke frame. E is an evaluation function. If E P W is equal to 1 and where W prime is belong to R, then E P W prime is equal to 1. If E A P P W belongs to coradical and W prime belongs to R, then E P prime W prime belongs to the coradical also. We say that W where W is a finite set of T cells is activated if EAP equal to 1, not activated if EPW is equal to 0, quasi-activated if EPW belongs to coradical, and not quasi-activated is EPW belongs to radical. Such kind of. Now let E is a formulas, the set of formulas, and W is a set of the Kripke frames also. The evaluation, C is an evaluation of function. C is an evaluation of evaluation of function. Then we have such kind of formulas for any W prime.
Non vero.
Sorry? Sorry? Is a function from formula Descartes product of the W into C, is evaluation function. Then we have such kind of situation for any W prime belongs to V. If W prime belongs to R, then we have this situation that E W phi is equal to R, then E W prime phi also equal to 1. Now also, if we have this kind of for any W prime belongs to phi W and W prime belongs to R, then A phi W belongs to coradical, then prime A W prime and phi also belongs to coradical. This is definitions, nothing else also. Now, if we have some evaluation, is for variables to the words of the frames to C. For a given formula of A, we call A phi activation. This we have this one because we evaluated variables by element of C. Then formula phi can computation what kind of evaluation have the E phi. It names phi activation. This is a way to represent the epistemic information changes after, say, an experiment that produces new information about the epistemic values of all points W from W capital. To know facts about evaluation of the formula phi means to know facts about possible variations of the epistemic states of the system and to check whether these variations can be described by a formula. It is worth to note that a single formula phi essentially represents a set of epistemic states. Actually, all such states defined by evaluations E that varies in the sets of all evaluations. In this way, a given formula represents a collection of epistemic states of the immune system in the frame, Kripke frame. It could be of interest to explore the possibility to check whether given collection of epistemic states we can find a formula representing such a collection. Now, corresponding literature, I can give you this one. The Nola, Grigolia, Turden is some monography also. Nola, Grigolia, Mickiewicz, Modal Epistemic Lukasiewicz logic with constant and application in immune systems. Nola, Grigolia, Lenzi on the lattice of all subvarieties of MV-algebras. Nola, Grigolia, Mickiewicz, Vitale, dynamic Lukasiewicz logic and its application in immune systems. Antonio de Nola, REVAZ, Grigolia, Gaetano Vitale, Epistemic Lukasiewicz logic of partial knowledge. For this one. Thank you for your attention.